Okay guys, so we're going to be looking at forces involved when there's objects which are connected together in some way or joined together in some way. And there's no new physics in here, it's just Newton's laws applied to the objects which are in some way coupled or joined together. Right, just had to fix the resolution on that there. So this is taken from virtual physics. This is the example that they use. After this we'll have a look at the example that is used on page 45 of your textbook, but it just looks at this context where you have a tractor which is pulling along a trailer, and if in this situation we are showing the force acting on the tractor, so that's what we would say is the engine force acting on the tractor. Normally how you would apply that is if you look at the system that is joined together, that's the tractor and the trailer, you would apply Newton's second law by looking at the whole system together. Right, so this force from the engine is pulling along both of these, so you would put their masses together and then you would use Newton's second law just to work out the acceleration, for example. In the study of the objects which are coupled together in some way, what we look at is we look at the forces that are acting between the two objects. Okay, and this type of force is sometimes called tension force. Okay, so we'll be looking at the forces involved that are acting between the two objects. Okay, so part of it we might be looking at the whole system, but we'll then break it down into looking at the forces acting on the individual component parts of that system. Okay, now the way that works is that the engine force exerts or acts on the tractor. Okay, but obviously you wouldn't get the kind of acceleration that you would expect to get if the tractor was not pulling a trailer. So this is going to have some impact. It's going to pull the tractor back, and we'll look at that force in just a wee minute. But you also need to have a force acting on the trailer, right, in order to move it forward. Okay, so what happens in here in the coupling between the tractor and trailer is you have what's called a tension force acting on the trailer. Okay, so that is the force that actually pulls the trailer along. So that is the way that the force is exerted on the trailer. It's really the tractor that's pulling the trailer along, of course. So basically this is a Newton's third law situation here, because we've got tractor pulling on trailer, right? So that tension in the connection, the parts that are joining the coupling that's joining the tractor to the trailer, so that tension pulls this trailer to the left, but every action force has an equal and opposite reaction force. So what you end up getting from that is you get a reaction force where the trailer exerts a force on the tractor. Okay, and it will be equal and opposite to the force that the tractor exerts on the trailer. So tension always exists in what we would call Newton pairs of forces. Okay, so you get the tension on the object at the back pulling it to the left, and you get the tension on the acting on the object at the front pulling it to the right. Okay, so that's the picture of what's happening in terms of tension. We're going to look at a simple example that's taken from page 45 of your textbook. Okay, so this is the scenario. So you've got a 7 kilogram block here, and it's connected in some way, so there's maybe some string or a rope connecting to this 3 kilogram block at the back. This is the applied force, right? So we're pulling along the 7 kilogram block with a force of 30 newtons. Okay, and what the situation here is, it's asking us to work out the acceleration of the blocks here, basically. So that's the applied force. We're to assume that there's no friction, or friction can be ignored, so we've just got one force acting on these two objects together. It shows you the tension force acting on the 3 kilogram block. Now that means that there's also a tension force acting on the 7 kilogram block. So that's your Newton pair of forces that we talked about in the first example. Okay, so 7 kilogram block pulls on the 3 kilogram block. Now, in order for that to happen, the tension needs to occur inside the rope here, right? Because the 7 kilogram, this block isn't touching that block, right? So the force comes about because the rope becomes tense, and then that's how one object exerts a force on the other. So that pulls the 3 kilogram block along. But as we said, Newton's third law, every action force is an equal and opposite reaction force, so you then get another tension force here, which pulls back on the 7 kilogram block. So 7 kilogram exerts a force on the 3 kilogram, 3 kilogram exerts a force back on the 7 kilogram block. Okay, so that's your Newton pair of forces. For the purpose of working out the acceleration, you can ignore what's happening in here, because what you can do is you can put these together to make one whole system. Okay, and that allows us to then calculate the acceleration of the blocks. Okay, so I'll just go through the working and we'll look at how we calculate the acceleration using Newton's second law. Okay, so that's the first part of the working there, guys. So we've got using Newton's second law, F equals m times a, and the mass of the system, right, so we're treating the whole system together, which you can do because we know that there's a 30 Newton force acting on the full system. So that's the unbalanced force. Put the two masses together, right, to give us 10 kilograms, and we're trying to work out the acceleration. Okay, so we're just at the stage here, the step where we're going to divide both sides by 10. Okay, cancel here and here, and that gives us the acceleration is 30 over 10, so the acceleration is 3 meters per second squared. Okay, so that's the working involved for that. Now, it might look as though we've talked about these two forces acting in between the two component parts of the system, but now we're ignoring them. We're not really ignoring them. This is the force that pulls the whole system along. The way that is able to work is it creates a tension force pulling the back block along, and a tension force exerted on this block here pulling it back the way. Okay, but we don't need to take account of those forces. It's not because they cancel each other out, because they act on different objects, but we can also just treat the whole system because there's only one force acting on the full system together, right, and that's the 30 newtons. Okay, so I know it seems a bit complicated, but that is how we start off the problem normally when you've got these tension forces. So we'll treat the full system together just as a 10 kilogram object which is being experiencing a force of 30 newtons to the right, and so we can use Newton's second law to work out the acceleration. And we're going to see in the next slide how we're then able to work out how much tension, what this force would need to be in between the two objects that are joined together. Okay, so now this diagram is taken from page 46 of your textbook, and you can see what we've done now in separating out the two objects which are joined together. So now just treating the 3 kilogram block which was at the back, and we're going to try and work out the force, the tension force which is required in order to pull that block along. Okay, so it's just again applying Newton's second law, but just to one of the objects. Okay, so I'll just go through the working for that now. Right, so using Newton's second law, F equals m times a, we already know that the 3 kilogram mass has to have an acceleration of 3 meters per second squared, because that's what we worked out in the previous slide. The whole system is moving with an acceleration of 3 meters per second squared. So what we're working out when we're calculating the unbalanced force here is we're working out the only force acting on the 3 kilogram block, and that's the tension. That's the force from the 7 kilogram block pulling the 3 kilogram block along behind it. So no friction acting, so the only force acting on it is T. So therefore T is equal to mass times acceleration 3 multiplied by 3 gives us 9 newtons for that tension force. Okay, so that's how we're able to then separate out just the object at the back there and just look at the forces acting on it. And we've found that in order to accelerate the 3 kilogram block with an acceleration of 3 meters per second squared, you would need to have a tension force of 9 newtons. Okay guys, so just for completeness, we're just going to look at the forces involved just on the front block, right, just so that we can get a complete picture of what's happening with the forces acting on these two objects. So we said that the block at the front experiences this force of 30 newtons. Now if you were to work out the acceleration that it would result in, your acceleration would be too high if you just use 30 newtons and the mass of 7 kilograms. So what we're missing here is that the acceleration actually ends up just over 4 meters per second squared. But remember, the 7 kilogram block exerts a force on the 3 kilogram block. That was the tension that was pulling the 3 kilo block forward. But by Newton's third law, there is also a force that the 3 kilogram block exerts back on the 7 kilogram block. So that's your reaction force, if you like. So that's that tension force. Okay, and we also said that the tension force, because it's a Newton pair with the other tension force that we calculated above here, it means that that one will also be 9 newtons. So you can then apply Newton's second law, where we know that that is 9 newtons. So the unbalanced force here is going to be 30 take away 9. Okay, because you've got the applied force to the right and you've got the tension force to the left. It's a 7 kilogram block and we're working out the acceleration. So that gives us 21. So your acceleration is going to be 21 over 7. The same 3 meters per second squared that we calculated in part 1. So that's just for completeness, just to show you the full picture of what's happening for the block at the front of the system. Okay, so all that has to sort of make sense. Right, and here what we're doing is just separating out the 7 kilogram block and looking at the forces involved. So I hope that makes sense, guys. There's a few questions, tutorial questions on this in your textbook on page 46, 47. There are some of the questions that involve objects that are not tied together like these two were, but are just in direct contact with each other. And there's an example of that which is on page 46. Okay, but hopefully that makes sense, and hopefully the worked examples that you look at in the textbook make sense, and you can try some of those tutorial questions. And as always, guys, if you've got any questions, just get in touch and we can, if there's anything you want me to go over in more detail, if you want me to do any tutorial solutions on video, then that can certainly be arranged. Okay, have a good day, guys. Thanks.